Proof. So in this recording, we will look at the topic of proof. First of all, we need to learn how to express certain numbers as letters. We'll be using a lot of algebra in this topic. So if we're asked for an integer, n can be any integer. An integer is a whole number. If you were looking at consecutive integers, so what does this word consecutive means? Consecutive numbers would be like 3, 4, 5 numbers, counting numbers next to each other. So our first integer was n. Our next consecutive integer would be n plus 1. Next one, n plus 2. Okay, 2n is an even integer. Why is it an even integer? Because it's in the 2 times table. Has to be even, because any number in the 2 times table is even. So if we were to look at consecutive even integers, the first one was 2n. 2n plus 1 would be odd. Our next one would be 2n plus 2. 2n plus 3 would be odd. So 2n plus 4. If we were to look at an odd integer, 2n plus 1 would have to be odd. It's an even plus 1. I think that should be enough. Let's just have a look at a couple of examples and then we'll see if we need to add to this page at all. Prove algebraically that 2n plus 1 squared minus 2n plus 1 is an even number. Right, you've got to be careful here with this minus. Let's expand our brackets first. 2n plus 1 squared is a double bracket. 2n times 2n, 4n squared. 2n times 1, 2n. 1 times 2n, 2n. 1 times 1, 1. And we're subtracting 2n plus 1. Now let me just simplify and collect the like terms here first of all. Now because we've got a minus outside our bracket, we're actually subtracting everything in that bracket. I'm going to times everything by minus 1. Minus 2n, or minus 1 times 2n is minus 2n. But that minus, we're timesing by the 1. Minus 1, if you like. That's a minus 1 really, because it's one bracket. Times positive 1 is minus 1. Or you could think of it as minus plus 1. A minus and a plus is a minus. When you're subtracting, a positive number is the same as subtracting. Collect the like terms. 4n take away 2n. 1 take away 1. So we're left with this expression here, 4n squared plus 2n. We want to prove that it's an even number. So I'm going to take out a factor of 2 into a single bracket. Divide 4n squared by 2, 2n squared. Now, because I've taken 2 outside my bracket, I've proven that it is in the 2 times table because 2 times our number. I'm going to put therefore even. Okay, we're going to look at quite a few questions as examples. Question 2, another example. Again, let's be careful of this subtract. Let's expand our brackets first of all. We're going to write both as a double bracket. Three times 2n is 6n. Now I'm just going to be careful here. I'm going to leave this in a single bracket even after I've expanded it because of this subtract. Got to be really careful there. Let me just simplify. Right, I'm going to deal with this minus outside this bracket. There'll be minus 4n squared minus 12n is plus 12n minus positive 9 is minus 9. Now we can collect the like terms. 4n squared minus 4n squared, 0. 12n plus 12n. 9 take away 9, 0. Is this a multiple of 8? So I need to show by putting it in a bracket with 8 outside the bracket. Yes, it is. So therefore, multiple of 8. The product of two consecutive positive integers is added to the larger of the two integers. Prove that the result is always a square number. The product of two consecutive positive integers. Product means times. So my first integer is going to be n. The next integer would be n plus 1. The next consecutive integer would be n plus 1. The product of two consecutive positive integers, so let's times them, is added to the larger of the two integers. So adding that to the larger of the two integers, which would be this one. So let's work that out. Simplify. Prove that the result is always a square number. So can you write this as a square? So let's factorise it. So we need two numbers at times to get 1 and add to get 2. 1 and 1. So as you can see, this is a square. So therefore, square number. Question 4. Prove that the square of an odd number is always one more than a multiple of 4. 2n is an even number. 2n plus 1 is odd. Square of an odd number, so we need to square it. Expand the brackets here. Simplify. So we're proving that it's always one more than a multiple of 4. Let's get our multiple of 4 here by taking out a factor of 4. So that's our multiple of 4. That's one more. So therefore, one more than a multiple of 4. I just might put an arrow here to show this is a multiple of 4. Okay, so I've got 2 pages of questions, 3 on each. Maybe have a go, put me on pause and unpause when completed to see if you got it correct. Okay, question 1. We're showing that n plus 3 squared minus n minus 3 squared is an even number. So let's expand this first set of brackets first. Leave this in a bracket. Simplify. Remember, I'm subtracting everything inside this bracket here. Gotta be really careful with this minus. In fact, before I do that, let me simplify. Okay, now I will remove my bracket. Minus n squared minus 6n minus positive 9. Right, I'm going to collect my like terms over here. N squared minus n squared disappears. 0, 6n plus 6n, 9n plus 9n, 0. So it is an even number. So it's even, you need to take out a factor of 2. So therefore, even. Prove algebraically that the sum of any 3 consecutive even integers is always a multiple of 6. So our first even integer is 2n. 2n plus 1 will be odd. 2n plus 2 is the next even integer. 2n plus 4. The sum of these, so the sum means you're adding them together. Six n plus 6. Take out a factor of 6. So therefore a multiple of 6. X is an integer. Prove that is a square number. I think I'll do this on a fresh page. Okay, so let me rewrite the second term here as a double bracket. Expand your brackets. Right, 2x times 4x. Now don't forget here, this is negative 2x times negative 3. Right, let's simplify this now. 9x squared, take away 8x squared is x squared. 3x add 3x add 6x. 12x. 35 plus 1. Right, let's put it in a bracket. Factorise. Times to get 36, add to get 12. 6 and 6. I can write it as a square. Okay, 4, 5 and 6. Again, have a go at these and see how you get on. So prove algebraically that the difference between the squares of 2 consecutive integers is equal to the sum of these 2 integers. Right, so let's break this down. The difference between the squares of 2 consecutive integers. So let's have our 2 consecutive integers. There's n and n plus 1. So we want the squares of them and the difference, so we're subtracting them. So it has to be the square of the first one, because it's bigger. Subtract the square of the second one. Right, and I'm going to expand the brackets and simplify. Right, so I'll collect our like terms here. N squared take away n squared. N plus n. Add 1. Right, now is that equal to the sum of these 2 integers? Let's add them together. Yes, it is. Okay, so using algebra, prove that given any three consecutive whole numbers, the sum of the square of the smallest number and the square of the largest number is always 2 more than twice the square of the middle number. Right, so 3 consecutive whole numbers. The sum of the square of the largest number, the smallest number and the largest number. Okay, well, I could have left that, but let's write that out again. Okay, let's work this out first. Let's simplify. Okay, it's always 2 more than the twice of the square of the middle number. So let's square this middle number. Okay, so 2 more than twice the middle number. Let me just write that down. 2 more than twice this, basically. So we need to double that and add 2. And then we should get this expression over here. So, yes, we have proven that using algebra. Okay, last question here. Prove algebraically that the difference between the squares of any 2 consecutive odd numbers is always a multiple of 8. So the difference, so we're subtracting the squares of 2 consecutive odd numbers. So 2n plus 1 is our first odd number. 2n plus 2 is even, so 2n plus 3. We're finding the difference of them, so you need the biggest. Subtract the smallest. I'm going to leave this in a bracket because there's minus outside. We simplify. Simplify. No, I'm going to expand this bracket to get rid of this negative outside it. Minus 4n squared, minus positive 4n, minus positive 1, which gives us, oh no, 0, 12n take away 4n is 8n, 9 take away 1 is 8. Let me factorise it by taking out 8, then it shows it's a multiple of 8. So therefore, multiple of 8.